time to do the 2020 methods WACE exam. Then after this, hopefully today, I'll also do the 2023 one. So yeah, unfortunately, I don't think I'm gonna get these videos out like before the WACE exam, which is gonna kind of suck. Just because my chemistry exam, my methods exam, and my physics exam all kind of squashed together. But you know, it is what it is. So 50 minutes. Time to start the timer. I almost did it. Okay, Ashley and Xavier. Wait, let's see how many pages we got first. 11. Okay. Here we go. Playing a board game requires them to use the spinner below. And the result stops. Okay, so result A. What is the probability that B is never a result? So if B is never a result, then we have 1, 2, 3, 4, 5 out of 8. So then this is 5 to the 8 to the power 3, which is equal to 125 over 64 times 8 is 32, 480, 512, 480 and 32, yep. Okay. B is minus the number of times B is the result, and the spinner is spun 3 times. So this is 125 over 512. If it's 3 times, then it's 3 to the power of 8, so this is 27 over 512. If it's spun once, then we're going to have, why is there like no working space? We're going to have 1 over 8, no sorry, 3 over 8 times 5 over 8 to the power of 2. So 3 times 25 over 512, so 75 over 512. Am I doing this right? Oh, and it could be any 4 of them, right? Or any 3 of them, I mean. So 3C1, which is 3, could be 3 factorial over 2 factorial, then 1 factorial. That just becomes 3 and 1, so it'd be 225. And then similarly, 3C2 is going to be 3 factorial, 1 factorial, 2 factorial. So again, that's just 3 times 5 on 8 times, this is going to be 9 on 64. So 15 times 9 is 90, 145, 135 over 512. See that these add up, so that's 350, 485, 505, 512. Yep. Okay, nice, with the right probabilities. Okay, I guess I'll leave that there. I'll say maybe probability is equals 1. X equals 1 is equal to that. Probably that x is equal to 2 is equal to that. Okay, determine the mean and variance of the above distribution. This is the calculator free section right here. It is, okay. So the expected value of x is going to be 0 plus 225 over 512 plus 2, so 270 over 512 plus 3 times 27, so 81 over 512. So this is going to be 495 plus 81, 571 over 512. 576. 512. Do they really want me to divide that? I don't know. 288 over 256. 144, 128, 72, 64. Divided by 4, 36, 18, 16, 18 on 16 is 9 on 8. 9 on 8. Okay. And then variance of the above distribution. So then variance of x is equal to maybe times 0. So 0 minus 9 on 8 squared times, what are these? Am I doing this wrong? I feel like these numbers are a bit high. I don't know, okay. Minus 9 on 8 times 125 over 512. That's going to get ugly really fast. What the heck? Return the mean. Okay, plus 1 minus 9 on 8 squared times 225 on 512 plus 2 minus 9 on 8 squared times 135 on 512. Oh god. Plus, I'm going to be able to put this in. So I may have put at the bottom 3 minus 9 on 8. This cannot be 2 marks. I must be doing something wrong. 27 on 5, 112. This is 8164 times 125 on 512 plus, that's going to be negative 1 on 8, so 1 on 64 times 225 on 5, 112 plus 16, so 7, so 49 on 64 times 35 on 5, 112, and then plus 24, so 15 is 225 and 64. There's no way they expect me to, okay, I must be doing something wrong. What are these fractions? Times 8 is 64. And 32, 480, 215. What? There's no way they expect me to calculate that. 2 months? Wait, no! I'm so stupid! There's a formula for this. Oh my god. I think there's a formula for this. Okay, wait, hold on. Let me get my formula data sheet out. Give me a second. Alright, we're back. Send me my timer centered. Okay. There's definitely a formula for this. Okay. Binomial distribution. Our mean is NP. So NP, so 3 times and the probability. Wait, no, it's not. Because it's not binomial. Yeah, never mind. I have no idea then. Okay, I'm just gonna continue. Maybe if I have time I'll come back and figure that out. So h dash of x is going to be equal to, derivative of the top is going to be e negative x cosine of x minus derivative of cosine is negative sine. So sine of x e to the negative x all over cosine squared of x. So then h dash of x, of pi, it's going to be negative e to the negative pi cosine of pi. Cosine of pi is negative 1 plus sine of pi, which is going to be 0, times e to the negative pi. Excuse me. All over cosine of x. So cosine of pi is again negative 1 squared. So this is just going to be e to the negative pi all on 1, or let's say it's 1 on e to the pi. Okay, and then next, the graph of the cubic function f of x equals ax to the power 3 plus bx squared plus cx plus d is shown below. A turning point is located at 1, 0 in the shed region in an area of 3, 2 units. This is information to determine the values of a, b, and c. So f dash of x is equal to 3ax squared plus 2bx plus c. A turning point is located at 1, 0. Turning point at 1, 0. So then f of 1 must equal 0. So then we know that a plus b plus c plus d must equal 0. And then f dash of 1 must equal 0 as well. So we know that 3a plus 2b plus c must equal 0. And the shaded region shown on the graph has an area. Ooh, with an inflection point there as well. So then f dash dash of x is going to be equal to 6ax plus 2b. F dash dash of 0 is going to be equal to 0 because of an inflection point. If our cavity changes, so then we know that 2b equals 0, so we know that b equals 0. B equals 0. Okay. Then I think we have to do the area now. So the integral from 0 to 1 of ax to the power 3 plus cx plus d is equal to 0. So then we have that a on 4, ax to the power 4 on 4 plus cx squared on 2 plus dx, just plus dx. 1 to 0 equals 0. So we know that a on 4 plus c on 2 plus d must equal 0. And then we know that a plus 2c plus 4d equals 0. And then we also know that 3a plus, let's do a plus c plus d equals 0. And then 3a plus c must equal 0 because our b is 0, so we can ignore all of that. So then let's substitute in. Oh wait, no, sorry, that's not equal to 0. That's equal to 3 on 2. Oops. 3 on 2. 3 on 2. So let's see. If I can get c equals negative 3a, then this becomes a minus 6a, so negative 5a plus 4d must equal 3 on 2. And then I have negative 2a plus d must equal 0. So if I do minus 4 of the bottom one, I'm going to be left with 3a plus 3 on 2, so then a is going to be equal to a half. D must be equal to 1, and C must be equal to negative 3 on 2. So negative 3 on 2, 3a equals 0, A plus C is negative 1, plus D is 1 is 0, and I think everything else is good, so yeah, pretty happy with that, and then let's put at the bottom here, B equals 0. Okay, next page, the heights reached by a species of small plant at maturity are measured by a team of biologists, the results shown are the histograms of relative frequency below. Determine the probability that a mature plant of a species which is no more than 30 centimeters, no higher than 30. So, what do they call it? Let's say, we'll just say P of X is less than or equal to 30. It's going to be equal to 0.4 plus 0.04 plus 0.08, so 0.12. If a mature plant reaches a height of at least 32 centimeters, what is the probability that its height reaches above 38? The probability of x is greater than or equal to 38, given that x is at least 32. So its height is above 38 is 0.02 all over greater than 32 is 0.26 plus 0.18 plus 0.1 plus 0.02, which is equal to, this is going to be 2 on, that's going to give me 44, 54, 56, so 1 on 28. 5, 4, 5, 6, at least 32. So before 32, 0.44. Yep, that is minus that. Another team of biologists is studying the mature heights of a species of hedge. The height h meters has a probability density function. H is given below. What percentage of hedges from this study reaches a mature height of less than 2 meters? So then probability of h being less than 2 equal to, I'm going to have 1 to 2, because my lower bound is 1, not 0, and then it'll be h minus 1 all on 5 bh. So I can write this as a fifth of h squared on 2 minus h from 2 to 1. So this is going to be a fifth of, let's see, we have 4 on 2 minus 2, it's going to be 0 minus, that's going to be 1 on 2 minus 1. So that's going to be negative a half, but minus that's going to be a half, so 1 on 10. Determine the value of k. So we know that from below 2 is a tenth, so that 2 to 4 of kh squared dh must equal 0.9 because it must be the remainder. So this is the same as kh to the power 3 on 3 4, 2 is equal to 0.9. So I have that k, what's 4 to the power 3? 4, 16, 64. So 64 k all over 3 minus 8k on 3 equals 9 on 10. So now I'm going to get 56k on 3 equals 9 on 10. So we get 27 on 560. Is there any common factors? 1, 2, 3. Maybe I can do, so that 28 times 5. Wait, no, never mind. I don't think there's anything that I can do here. 27 on 560. It might be? It probably is. 300, 260. Okay. That's fine. The graphs f and g are displayed below. Evaluate the derivative of f of x at x equals 3. X equals 3, so that's just going to be a derivative of -1. So f dash of 3 is going to be equal to -1. Evaluate the derivative of f of g of x at x equals 5. So d dx f of x g of x equal to derivative of the first one, derivative of the second, plus x dash of x. Oh no, this is just f of x. So then f dash of 5 g of 5 plus g dash of 5 f of 5 is equal to, derivative of 5 is going to be 1. 1 times the g value at 5 is 5 plus the derivative of g at 5 is -2 and then the value of f at 5 is 5. So it's going to be 5 minus 10, so -5. Evaluate the derivative of that at x equals 1. So d dx is going to be equal to derivative of the inside function times derivative of the outside of that. Yeah, g of x. So then at x equals 1, d dx is going to be equal to derivative of g of x at 1 is +2. 2 times the and then g of 1. G of 1 is 3. So the derivative of f of x at 3 is -1. So it's going to be -2. Because we had like 2x minus 3 to the power 4. We have the derivative of the inside function, which is 2. Derivative of the outside function, which is going to be 2x minus 3 power 3. Yes, okay. But yeah, g of 1 is 3, derivative of 3 is that. Okay, consider functions f equals f of x. The function g equals f equals a is vertical translation of f by a means. Express the function g of x equals ln of x in terms of the vertical translation of f in the form g of x. So g of x is equal to ln of x plus ln of 4 ln of 4 plus ln of 4, then translated for units up, ln 4 units up. The function's vertical dilation, C. Express the function C in the vertical dilation of f, stating the scale factor. H of x is going to be equal to half of ln of x. It's going to be a half of f of x. So vertical dilation scale factor half. And then there's a horizontal dilation of a scale factor of 1 over b. Express the function plus 4 in terms of horizontal dilation of f, stating the scale factor. This would be equal to ln of x plus ln of e to the power 4. So this is equal to ln of e to the power 4x. So then horizontal dilation of 1 over e to the power 4. Okie dokie. 10. Determine the coordinates of the x-intercepts of f. You may wish to consider the factorized version of f. What's that? So the x-intercept of y equals 0. So y equals 0. 0 is going to equal e to the x times e to the x minus 4. So e to the x equals 0. I'm going to have no solutions. Then e to the x minus 4 equals 0. E to the x is going to equal to 4. So then x is going to equal to ln of 4. So then therefore, I'm going to have ln of 4, 0. Show that there is only one turning point on the graph of f, which is located at ln minus 4. So dash of x going to equal to 2e to the 2x minus 4 e to the x. If turning point, then f dash of x will be equal to 0. So then 0 is equal to 2x minus 4e to the x. So then 2e to the x is going to be equal to e to 2x. So then 2 is going to be equal to e to the x. So then x is going to equal ln of 2. And then we know that f over ln of 2 is going to equal e to the 2 ln of 2 minus 4e ln of 2. And then this is going to equal 4 minus 8. Going to equal negative 4. Therefore, turning point at ln of 2, negative 4. Determine the coordinates of the points of inflection of f. So f dash dash of x. Maybe I'll say if inflection f dash dash of x equals 0. F dash dash of x is going to equal 4e to the 2x minus 4e to the x. So then f dash dash of x equals 0. So now I know that 4e to the x is going to equal 4e to the 2x divided by 4 and divided by e of x. So 1 is going to equal e to the x. So x is going to be equal to ln of 1, which is 0. 4 divided by e to the x equals 1. It's ln of 0. And then f of 0 is going to equal 1 minus 4, so negative 3. So, therefore, inflection at 0, negative 3. Okay, sketch the function. The turning point, approximate value is a natural logarithm function provided may be helpful. Okay, so let's go 0, negative 3 first. And then turning point at natural log of 2, negative 4. So 0.7, 0.7, negative 4, right about there. 2, negative 4. And then I have natural log of 4, 0. Natural log of 4 is 1.4, 0. So like that. Wait, does e to the x ever equal 0? I don't think so. Okay, so I something like this. Bada bing. No. Y is equal to 0. What's going to happen with this inflection point? Because it's not a maximum. I don't have another 0. Okay. X-intercepts of f. E to the x, e minus 4. Sure, there's only one turning point to look at. ln of 2, negative 4. Determine the coordinates of the points of inflection of f. So the second derivative is 4e 2x minus 4e to the x. So 4e to the x outside of e to the x minus 1. So then x has to equal 0. E to the x doesn't equal 0. Points of inflection of f. What the heck? If I let this equal 0, well, no, let's say 0, so then if x is 0, then yeah, that's just 1 minus 4, so negative 3. So 0, negative 3, but it's an inflection point. Okay, let's just put here 1.40, and then here is 0.7, negative 4. What am I doing for the left hand side though? It's an inflection point, so my concavity changes. Do I just like go off like this? Is that what happens? Oh, maybe? Because it's an inflection point. Let's keep it down, but I never reach 0. Okay. Let's just like continue just going up like that. An inflection point here. Okay, let's think. It's not a turning point. It's not a horizontal inflection point because my first derivative isn't 0 there. And it can't be that because then I would have a maximum value here. So I think the only thing is that it tends off towards 0. Oh yeah, no, that makes sense. Because then this becomes e to some very like large number, so 1 on e to the 100 minus 4 1 on e to 50 I think that's what I'm going to have to do. So it's just like that, I think, maybe? Negative 1. 1 on e to the 2 minus 4 on E. I don't know what that is. I think that's the only thing that makes sense though, really. So let's stick with it. Okay, let's figure out this first question. What on earth am I doing here? So, the spin is spun 3 times. There's a probability that B is never a result. 3, 4, 5. So 5 on 8. That. 25. 1 is 3. Times 3 on 8. Times 5 on 8. On 5 on 12. So 75 times 3 is 110 and 15. Okay. If x equals 2 is going to be 3 times 5 on 8. So that's going to be 45. Times 360. Sorry, 15 times 9. 15 times 9 is 90. And 45 is 135. 512. The mean and the variance of the above distribution. Am I forgetting something? I think I am. I have to be forgetting something. What the heck, man? Can I divide 512 by 3? 300, 212, 180, 32. No. There's no way they expect me to be able to do this. What is the shortcut? Oh, I'm so confused. Defines the number of times B is a result when a spinner is spun 3 times. I need to do my e of x wrong, maybe. 0 times 125, so it's 0. 225, 270, and 81. So then the right would be 351, 225, 576. Oh. And 576 is 64. More than 512. Oh wait, I'm stupid. I just have to add up the numerators because these all have the same denominator. Wow, nice one. Nice going there. So 81 plus 125 is going to be 206. I don't have to calculate all of these because they have the same denominator. Oh my god. Wait, no, I do have to calculate them because 81 times 125. What is happening? Times 125. There's no way they expect me to do that. It's 225 plus 49 times 135 plus 225 times 27. 64 times 512. There's no way, right? Calculate free. I must be missing something. Sorry, I'm back. My dad just came in. I must be missing something. What was the thing I was looking at before? Wait. This is a binomial distribution, isn't it? Wait, it is. No, yeah. Oh, yeah. I'm so stupid. So mean. I think I was thinking that. I was thinking of Bernoulli, not binomial. Because I was thinking, wait, you either are or you aren't, but then there's 2 or 3. But no, because you either land on B or you don't. Oh, that's okay. So I think is so let's say maybe binomial. Therefore E of x is equal to, this is going to be NP, and N is going to be 3, and my probability of getting it yes is going to be 3 on 8. Yes, 3 on 8, yes, 9 on 8. Okay, then my variance of x is going to be, wait, did I say why I had to pause? My dad came in just then. We're going to watch Interstellar, but I might watch it in a few days. Variance of x is np, 1 minus p, so it's going to be 3 times 3 on 8 times 5 on 8. This has to be it. There's no way they're expecting me to calculate all of that. So 45 on 64. That would have all come down to 45 on 64. Okay, interesting. I don't think there's any common factors there. Okay, evaluate HMS. So derivative of the top is negative e to the negative x. Cosine of x. Derivative of the bottom is going to be negative sine of x. So that becomes positive plus e to the x. If I substitute pi in, e pi, cosine of pi is negative 1. Sine of pi is 0, negative pi to 1 e to pi. Pretty happy with this because these values all worked out. C plus D. Then probably the mature plants be no higher than 30 centimeters. So 0.4, 0.8, 0.04, 0.08. Read this again. Okay. A mature plant reaches a height of at least 32, or probably its height reaches above 38. So it's only 1. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 1 on 28, yep. That's definitely correct then. Another team of biologists studying the mature plants of a species of hedge. The height h meters has a probability density function d of h as given below. H minus 1 on 5 for 1 greater than that. So the percentage is less than 2 meters. So a fifth of h minus 1 dh, h squared. H squared, so So 4 on 2 is 2, minus 2 is 0. A half minus 1 is negative a half. So negative a half is exactly the same. Okay. Okay, h to the power of 3 on 4 on 2. So then 4 to the power of 3 is 4, 16, 64, 8, 56k. Let's do a 4, right? Yeah. 0. And then times by 3 divided by 10, 56. Yeah. Derivative of f of x at equals 3 and negative 1. Derivative of f of x at 5 is 1. G of x at 5 is 5. Derivative of g of x is negative 2. F of x at 5 is 5, so negative 5. Derivative of g of x, derivative of f of g of x. So then derivative of g of x at x equals 1 is 2. G of 1 is 3, derivative is negative 1, so negative 2. Translate the ln of h plus 4. Wait, h plus 4, that's ln of 4 units up. Scale factor of a half. Then this one. One turning point. So only one point of inflection. Two. Yeah, I'll rewrite this one as 4 e to the x outside of e to the x minus 1 equals 0. 4 e to the x equals 0, no source. I think that has to be the shape of the graph. Then ln of, let's see, ln of 4, 0, it's 1.4. And then ln of 2, 0.7. Alright, pretty happy with that. 2 minutes left. I'm just going to leave it there. And then we got calculator assumed coming up, so let's go. Do you know what? I just realized that, that I didn't label this point here. So let's label this negative 3, 0. Sorry, no, 0, negative 3. And then, pretty happy with that. Labeling clearly all x-intercepts to turning point and points of inflection. So here this is a min turning point. And other than that, I think it's pretty good. Labeling clearly all intercepts. Did the last exam have me label them? Or was it just any of the points? I can't remember. Whatever, I'll just write it. Axis. Oh, x-intercept. And then here this will be y-intercept. Oh no, this is also inflection, right? Inflection point. Okay. Nah, okay, now I have 50 seconds left, whatever. Goodbye. Okay, time to do the calculator assume section. I accidentally brought up the 2022 one, which I've already done. But yeah, got 2020, correct one this time. See how many pages we got to deal with. 17 page, wait, what? 17 pages. Okay, it's odd. Alright then, well, the last one had 21, there's 4 less pages. Okay, let's get started, let me center my timer, and let's go. The white x, normally distributed for mean, what proportion of the jumbo? So now I want the probability of x is greater than or equal to 67. So this would be norm CDF of 67 to infinity of standard deviation of 5 and mean of 60. It's going to be equal to, come on Cass, wake up. 67, infinity 5 of 60. And this says what proportion, so not percentage, 8/8. What proportion of jumbo eggs are less than 75 grams in weight? So I want the probability of x is less than or equal to 75, given x is greater than or equal to 67. And then this is going to be equal to norm CDF 67 to 75 or 5 of 60 all over 0.0808. So let's see, 67 to 65, 5 of 60, 0.0808, 0.9828. The heaviest fetch a higher price. What is the minimum weight of these eggs? So then I want to solve for norm CDF of x to infinity of 5 of 60 equal to 0.0005. Divided by 100. Yep. So then CAS, when we calculate CAS, x is going to be equal to 60, so comma there, equals that. I get actually 276.45 grams. Okay, a cake shop makes birthday cakes. A probability distribution of the cakes. So calculate the mean number of cakes or birthday cakes sold in a day. So E of x is equal to 0 plus 0.2 plus 0.5 plus 1.05 plus 0.4 is equal to 2.15. On Monday, the cake shop makes 4 birthday cakes. If each birthday cake costs $20 to make and sells for $50, what is the expected profit or loss on that day? Each birthday cake costs $20 and sells for $50. Then it's just y 50 minus 20 of x, which is going to be 30x. So then the expected value of x is equal to mean number of birthday cakes sold in a day. E of x is just going to be 30 times 2.15. So $64.5. On Tuesday, the shop makes 3 birthday cakes. Let the random variable y denote the number of birthday cakes not sold on that day. I think I've seen this because someone was asking me about it in the chat, in the methods chat, but I haven't done the exam yet, so this is kind of cheating, but oh well. On Tuesday, the birthday makes 3 cakes, and denote the number of cakes not sold on that day. So this is just equal to probability of y equals 0. Probability that x is equal to 3 plus probability of x is equal to 4. So it's 0.35 and 0.1. 0.45. Obtain the probability distribution of y. Makes 3 cakes. Denote the number of cakes not sold on that day. So let's say y, no, small y. Probability of y is equal to y. So if it's 0, 0.45. if it's 1, so if there's one birthday cake not sold, that means that they only sold 2, so 0.25. There's 2, 3. So if there's 2 left over, that means they only sold one of them, so 0.2. And then if there's 3 left over, they sold one of them, so 0.1. Does this add up to 1? Yes. Okay. That's good. Three birthday cakes. These 3 birthday cakes not sold on that day. Okay. Water flows into a bowl at a constant rate. The water level H is measured in centimeters, increases by the rate. Determine the rate that the water is rising when T equals 2. So H dash of 2 is 8 plus 1 all over 8 plus 2 plus 1. So that's 9 on a, okay, it's an odd number to choose, 9 and 11. Explain why h of t equals that. So we'll say that h of t is the antiderivative of 4t plus 1 all over 2t squared plus t plus 1 dt, which is equal to ln of 2t squared plus t plus 1 plus c. Determine the total change in the water level over the first 2 seconds. Is this in seconds? Yeah, t is in seconds. So then delta h is going to be equal to 1 to 2 of 4t plus 1 all over 2t squared plus t plus 1 dt. So this is going to be ln of 2t squared plus t plus 1 from 2 to 1. So we get ln of it's going to be 11 minus ln of 3. So ln of 11 on 3, or 11 divided by 3, 1.299 or 1.30, is it centimeters? Yep. The water is then filled and the water level reaches 56. If the bowl is initially empty, determine how long it takes for the bowl to be filled. So then we know that, so we can say that delta H is going to be equal to ln of 56. So then we can say that from 0 to some k of 4t plus 1, 2t squared plus t plus 1 dt is going to be equal to ln of 56. So then we'll do solve on a CAS. K is equal to 0 to y of 4x plus 1, 2x squared plus x plus 1 dx equals ln of 56. And then solve. No solution, because I didn't put give me y. K is equal to 5 or negative 5.5. Clearly k has to be greater than or equal to 0, therefore k must be 5. So then 5 seconds, therefore 5 seconds. Wow, 5 seconds does not seem like a lot. What the heck? 5 of 4x plus 1, 2x squared plus x plus 1 dx. Standard. And yeah, that's correct. Wait, hold on, I'm gonna pause real quick. Back, just have to put some timers on. Alright, the y equals x plus c is tangent to the graph of f of x. Obtain the coordinates of the intersection point of intersection. Graph f equals x. Take the coordinates of the point of intersection. So then let's see. F of x is going to be equal to e of x if tangent I'm going to say that y has gradient of 1, e to the x is equal to 1, so then x must be equal to 0. And then, so the coordinates must be 0, 1. What is the value of c? Or c must be equal to 1 then. Sketch the graph of f of x and the tangent on the axis below. And here is the tangent. 0, 1. Call this f of x, and this is x plus c. Just like that. Evaluate the exact area between the graph of f of x, the tangent line, and the line x equals ln of 2. Area. Wait, let's find when they intersect. So then x equals ln of 2. Oh no, I know my boundaries already. So 0 to ln of 2. I'm going to go from 0 to some line by ln of 2. Okay. Ln of 2 to the graph of f of x, so e to the x minus x minus 1 dx. X minus 1 is 2. 0 ln of 2 of e to the x minus x minus 1 dx. And standard is negative ln of 2 squared on 2 minus ln of 2 plus 1. Can I simplify that? Doesn't look like it. Yeah, I'll say unit squared. Given that g of x is the inverse function of f of x, right, the definite integral that could be used to determine the area between the graph of g of x, the x-axis, and the line, and 2. We'll say that g of x equals ln of x. Graph of ln of x. So it's going to be something like this. The x-axis. Oh, okay, so it's from here. So ln of x equals 0, x is equal to 1. Therefore, we just need to go from 1 to ln of 2 of ln of x dx. We just have to write a definite integral. I have to evaluate it. Okay. Question 8. Page 8, question 12. It's estimated that 20% of small businesses fail in the first year. As Business Advisory Group takes a random sample of 500 new businesses that started in January 2018. An analyst employed by the group. Wait, this is 21 marks? Jesus. An analyst employed by the group suggests the use of binomial distribution is appropriate in the case. Okay, what is the probability that at most 120 businesses fail in the first year? So then let's say x is a binomial with 500 and 0.2. Let x equal number of failed businesses. Wait, failed businesses. So then the probability that x is less than or equal to 120, at most 120 businesses fail in the first year. It's going to be a binomial CDF. From 0 to 120 of it? 500 to 0.2. I forgot if it's the percentage or if it's the number first. I'm pretty sure it's the number. Let's see in a second. So binary CDF 0 to 120 of 500 is 0.2. So 0.9877. What is the approximate distribution of the sample proportion that failed by the end of the year in this sample? Justify your answer. So we'll say n greater than 30, therefore normal distribution. Let's just do NP. NP is going to be 500 times, because it says justify, so I'm like, maybe I have to do a bit more. 100, which is greater than 10. And then n of 1 minus p is equal to 400, which is also greater than 10. Okay, so then mean is going to be the 0.2. And then my standard deviation is going to be 0.2 times 0.8 over 500. 0.2, 0.8, 500 is 0.0179. Therefore, let y approximate normal distribution to 0.179 squared. What is the probability that the sample proportion of businesses that fail by the end of the year is less than 0.8? So what probability of y being less than or equal to 0.18? So that's going to equal normal CDF, negative infinity to 0.18 of my standard deviation, which is 0.0179, and my mean is 0.2. So this is 0.1319. By January 2019, 90 of the 500 new businesses will calculate 90% confidence interval fail in the first year. So I just say cast stats interval confidence equal 0.95, x is equal to 90, n is equal to 500. And then it's going to spit that out. So let's go statistics, calculation interval, one props, one sample, what am I looking for again? Proportion, one proportions of t, 0.95, 90 of 500. So then CI, confidence interval, is 0.1463, less than or equal to P, less than or equal to 0.2137. Oh my god. The Business Advisory Group believes that the proportion of new businesses that fail within a year can be reduced by providing financial advice. They took another random sample of 500 businesses that started in January 2019 and provided them with regular financial advice. In this random sample, at the end of the year, 80 businesses had failed. Calculate the sample proportion and the margin of error at the 95% confidence level. This one was just calculate the confidence interval. Yep. So sample proportion, so P hat is equal to 80 on 500, which is going to be 8 on 50, so 0.16. And then margin of error, so K equals 1.96 for 95% confidence. Hold on, I need to sneeze. Ugh. God, I'm dying, guys. No, actually, no. The paper has been pretty alright recently. Let me make sure my 80 on 500 calculation is correct. Yep, okay, and then so the margin of error, 1.96 square root 0.16, 0.84 all over 500. It's going to be 0.0321. Calculate 95% confidence interval to proportion of businesses that failed. What do you conclude regarding the value of the financial advice provided to new businesses? So calculating CI is going to be 0.16 minus 0.0321 less than or equal to P less than or equal to 0.16 plus 0.0321. So 0.1279 less than or equal to P less than or equal to 0.1921. Looks like it did. Actually, no. Large overlap to this. So I'm going to say large overlap of confidence intervals, 95% confidence intervals of this CI the previous years 95% confidence interval for proportion of failed businesses. It is slightly lower, but I don't think it's meaningful enough. Because 0.14, that it's going to be like that. So large overlap. So I'm going to say no, not effective. Confidence or proportion of failed businesses. Hence, financial advice was so. Ooh, wait, hold on. I'm gonna say no evidence. I remember this time. No evidence, or not enough evidence. To conclude that financial advice was effective. Regarding the value of the financial advice provided to the new businesses. Careful value was minimal. Value of advice was minimal. 2% less. If the sample size reduced, what would the effect be on the confidence interval? So margin of error proportional to 1 on n. If n decreases, margin of error increases. Or excuse error. If n decreases, margin of error increases. Hence, confidence interval will increase. Get larger or wider. State two assumptions that the analyst made in recommending the use of binomial models in this case, and discuss whether they are valid. Either fail or you don't. A success. Success or failure. I think this is. Let's see. guess so. You either fail or you don't fail. This is valid. But there are like edge cases where like you're almost failing, like maybe you're barely getting by, but then I guess you are still making money at that point. Okay, I'm gonna say yeah, this is valid. As it is clear if a business has failed, E.G no longer operating, or not, should be still operating. And then the other one is that proportion of or probability of a business failing is constant for all businesses. This is not valid. This is not valid as it can be determined, as it can be influenced by factors like competition, which industry, funding, etc. Okay. Oh, you're kidding me. How much should I lose? Okay. Well, I guess I'll be back. Okay, we're back. I finished writing it. I added a little thing. I said here that this is a Bernoulli trial. It has to be a Bernoulli trial. And I added here that it's prior funding in specific industry. Yeah. Okay. A company manufactures small machine components. They can manufacture up to 200 of a particular component in one day. The total cost in hundreds of dollars incurred by manufacturing. The cost is given by Celix, where X is the number of components that we produce on that day. Determine the total cost of manufacturing 20 components in one day. So let me do X, ln of 2x plus 1, 3 minus 2x plus 120, given X is equal to 20. So it'll be $104.76. Skips the graph of all of that. 0. No, not statistics, sorry. Graph and table. Root of all view, and boom. Wait, no. Main. Copy U. Boom, 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 boom. Zoom out a bit. Okay, so analysis, G solve. Let's go maximum. The maximum is 120. 3, 4, 5, 6. Oh, I think they did this on purpose. Sorry, 120. 100, 80, 60, 40, 20, 0. And that's C of X, and then X. Manufacture up to 200 particular components. So this will be 200, 150. Look at how nice they are, making the graphs nice and even, unlike physics. God. We need a 10 to 2, 10. Okay. And then so analysis, maximum we start at 120. There's a minimum point here actually. Let's find minimum. Is at 74 and 93. Is that? So 74 though is about there. And analysis minimum. 95, 80, 90, 95, 74, there, and then, oh, it goes up a lot. Maybe I should change my scale. My calculation, what is it at 200? It's 190 again. This is a bit of an odd graph at this scale. Should I have made it different? I mean, that should be fine, right? 120. Yeah, I'm just gonna stick with it. So I don't know how I'm supposed to do a smooth graph right down. Looks like that though. These all legit just look like what do you call it? This is so bad. I missed again. I'm calling it like that. Okay, reference to your graph. Explain how many components the company should manufacture today. The total cost is to be as possible, is to be as low as possible. Well, then it would need to be x times that. Total cost is equal to x. What am I referring to my graph as b? Because total cost. Oh no, C is a total cost. Okay, wait. For a second, I thought C was the minimum cost. I mean, not the minimum cost per component. Okay. Minimum at from B. Let's say this was 74 point. What was it again? Like 06 or something. 0.2 and then 95.4, 74.2, 94.4. You obviously can't, therefore should manufacture 74 components. 74 components. So 74, 75, so that's 95.5. It could also be 75, I doubt so. Okay, doesn't matter. Should manage 74 components. Can't manufacture 0.2 of a component, which would be a bit silly. Manufacture 0.2 of a component. So that total cost is the minimum. $94.4. should I give it 2 decimal places? Maybe. G solve minimum. 94.43. Cost is 94.43. Wait, that's 95. Wait a minute. 95. Is the minimum 95.43? Wait, it is, isn't it? Yeah. 24. No, 0.5. 43. Minimum of 95.43. Okay. 11. A suburban council hires a consultant to estimate the proportion of residents who use the library. Decides to estimate 95% confidence within an error. What is the minimum sample size should be selected? So then K equals for 95% confidence. K equals 1.96. Therefore, 0.01 equals 1.96 square root of 0.5 squared over n. Assume p hat equals 0.5 for largest confidence interval to within an error of 0.1. Okay, if the error is 0.1, you can go either way. So the largest margin of error and cas n is equal to squared over x is 9604. Therefore, at least 9604 people. If resource limitations dictate the maximum sample size to be managed as 500, what is the maximum margin of error resulting an estimating of 99% confidence interval? So for 99% confidence, not CI. Oh, I guess I could say CI. 2.576. I believe. Let's go normal CDF. So normal CDF, negative x to x of 1 0 equals 0.99. What is 3 standard deviations again? So negative 3, 3, 0 is 99.7. Yeah, okay. Anyway, I'm back. And then so we say assume p hat equals 0.5. Therefore, margin of error is going to be 576.5 squared all over 500. What is the maximum margin of error? Maximum margin of error. So 2.76 times square root of 0.5 squared divided by 500. Maximum margin of error is 0.0576. The consultant decides to select a sample by standing on the roadside outside the library at lunchtime and asking random samples whether these are library. 2 possible sources with the sampling scheme. Standing outside library. Or should we use its library? Library excludes the population of people, or excludes people who do not use the library at all / frequency. Leading to undercoverage. And then again, asking only outside of lunchtime. Asking only at lunchtime. Excludes people who may be out, who may be at restaurants, or simply won't be going to the library that day. That day, leading to undercoverage. For lunch. I'm still working. Simply won't be going to the library that day. Oh, a chef needs to use an oven to boil that. I feel like I've seen a very similar question. Anyway. Boil must reach 100 degrees to boil. The temperature T of 100 milliliters of water T minutes after being placed in the oven is set to T degrees Celsius, being modeled by the equation below. The chef placed a 100 milliliter bowl of water into an oven that heated to 200. What is the temperature of the water at the moment it is placed into the oven? So then T of 0 is going to be 200 minus 175. Is equal to 25 degrees Celsius. What is the temperature of the water 5 minutes after being placed in the oven? T of 5 is 200 minus 175 e to the negative 0.07 times 5 is 76.68 degrees Celsius. What change could be made to the temperature at which the oven is set to order? What change could be made to the temperature at which the oven is set? 5-minute boiling requirement. So does it require 100 equals TO minus 175 E negative 0.07 times 5 chaos TO is equal to x minus 175 e to the negative 0.07 times 5. This t is in minutes. Okay. So t is 223.32. Raise temperature. To 224 degrees Celsius. Or maybe yeah, I'll say 24 degrees Celsius. Because can you even set ovens to like degree. We'll say 223 if oven is that precise. Actually, I don't know. I'm just gonna stick with the 224. Okay. Assume that it's still 200. Determine the rate of increase in temperature of the water 5 minutes after being placed into the oven. Give your answer rounded to 2 decimal places. Determine the rate of increase in temperature. So then dt is equal to, it'll be 0, so 0.07 times 75. So it's 12.25 e to the negative 0.07 t. And then at t equals 5, dt 12.25 e to the negative 0.07 times 5. So it's 8.632 degrees Celsius per minute. Explain what happens to the rate of change of the increase in water as time increases and how this relates to the temperature of the water. To the rate of change in the temperature. So as T increases or approaches infinity, 12.25 e negative 0.07 t approaches 0. And its rate of change of temp decreases. Decreases as time increases. Raised to the temperature of the water. This is so. Such that when temperature equals 100, dt equals 0, as the water is boiling at this point. So the water is boiling at this time. It no longer increases. Therefore, temp no longer increases. The water is boiling. Okay, a large refrigerator in a scientific laboratory is always required to maintain the temperature between 0 and 1 degree Celsius to preserve the integrity of biological samples stored inside. A scientist working in a laboratory suspects that a refrigerator is not maintaining the required temperature. The scientist records temperature every hour for 7 days. Based on these measurements, the scientist concludes that the temperature T in the refrigerator is normally distributed with a mean of that and standing here up. Temperature ill. Okay, determine the mean and standard deviation in degrees Fahrenheit. So then temperature, expected value of T Fahrenheit is equal to 0.8 times 9 divided by 5 plus 32 is 33.44. And then standard deviation of the temperature in Fahrenheit is 0.4 times 9 divided by 5 plus 32, which is 32.72. Okay, determine the probability of the refrigerator above 1 degree Celsius. Give me an answer rounded to 4 decimal places. So then I need my normal CDF from 1 to infinity. Standard deviation of 0.4 and 0.8. So 0. Probability of T greater than or equal 1 is equal to 0.3085. The histogram gathers data by scientists is shown below and denotes the number of observations in each temperature interval. Okay. Do you agree that the normal distribution was appropriate model to use? Provide a reason to justify your response. It's a bit skewed. I would say no. No. Values are not symmetrical, or distribution is not symmetrical. Symmetrical around, or it's just not symmetrical. Okay, an alternative probabilities function proposed model is given by that. To determine the model, or determine the probability that the refrigerator temperature is above 1 degree Celsius using the new model. So this is going to be from 1 to 2 of 3 of 4 t to the power of 3 minus 3t squared plus 3t dt is equal to t greater than or equal to 1 is equal to minus 3x squared plus 3x dx. This gives me 0.3125. Next page 16. A small farm in which the fence of an area of the land so they can raise sheep. The area they have chosen has one border along a road, as shown in the diagram below. That is a very funky road. The enclosure is shown as the shaded area above. Okay, and has right angles F, E, G. They will want the combined lengths of the fencing from E to F and F to G to be equal to 500 meters. From E to F and F to G equal 500 meters. That the length of fence EF be equal to P and the length of the fence FG be equal to Q. If we locate the origin at point F and the x-axis along the line F of G, the equation defining the fence along the road is given by that. Show that the equation defining the area of the enclosure can be given in terms of Q as follows. So this would be so P plus Q equals 500. And then we want to say, let's go from, so the area of Q, area is going to be equal to, I won't say of Q yet. Okay, let's say that P equals, so then 500 minus Q, therefore R is equal to 10 sine of x on 15 plus 500 minus Q, and we know that the area is going to be equal to, I'm going to go from 0 to Q of 10 given in terms of Q as follows. Q at 15, Q squared plus 150. Okay, so 10 sine. I was thinking if I need to evaluate this as indefinite integral, which I think I do, minus Q. Okay, and then we'll say the x. So this is going to be equal to the negative 150 cosine of x on 15, because I need 1 on 15 there in front of the sine. So I pull the 10 out and then I put 15 times the 10 to get 150. It has to be negative because we're going from sine to cosine in an antiderivative. and then be 500 x minus qx from q to 0. So this is negative 150 cosine of q of 15 plus 500q minus q squared. Now when x is 0, that cosine is going to be 1, so we're going to have minus 150. And, oh wait, yeah, because it's going to be minus 150, but we're taking that away because it's lower bound, so plus 150. Okay, that looks good. Determine to the nearest meter the value of q that will allow the sheep to graze over the maximum area and state this maximum area. Do I have to do dA to q? I guess I will. Over dq is going to be equal to, so we're going to have to do 150 times 15, so 2250. And we're going from cosine to sine and an antiderivative, so it has to be sine. So negative 2250 cosine of, sine of q on 15 plus 500 wait, no, we're anti-differentiating. Sorry, no, we're differentiating. Okay, we're differentiating now with respect to q. So this will actually just be 10 sine of q on 10 plus 500 minus 2q, that one disappears, if max area, then dA dq is 0. So then 10 sine of q on 10 plus 500 minus 2q equals 0. Cas. Make sure I got this right. So differentiate negative 150 cosine of x divided by 15, 500x minus x squared. Standard mode, 2x 510. Okay, so then I'm going to do solve answer equals 0. You can do this in decimal, it's fine. Q equals 246 point, how does it want me to? Nearest meter, so 247. Maximum area, state this maximum area. Area of 247 is equal to, so pull this down, plus the 150, given that x is 243, or 247. 62,749. And then once it's to the nearest meter, so 50. Okay, the length of the fence EH is given by that. R is the first derivative of R of x, so R of x is 10. And it's x, so 10. Just rewrite R of x down here. I mean, yeah. And sine of x on 15 plus p. So then R dash of x is going to be 10 on 15, so 2 on 3 cosine of x on 15. P is a constant, so we will leave that as that. Hence, determine the total length of the fence required by the trainer to enclose that sheep with maximum area for grazing. I'll say here P is constant. Total area required by the trainer to enclose a sheep with maximum area grazing. e to h, that p, and then total length, so let's say when q equals 247 meters, p must be 253 meters. Therefore, total length see, like, is g to h the same length though? The length of e to h is given by so we'll say length. Let's just do this first. EH is equal to 0 to 247 square root of 1 plus 213 cosine of x on 15 squared dx is equal to 0 to 247, or square root of 1 plus brackets 203 cosine of x on 15 squared dx. E to h is, and then I think what it wants me to do is that g to h is going to be the value of the 10 sine thing at q meters. But this is 273.25. Then g to h is equal to 10 sine of 247 on 15 plus 253. Let's say r of x. R of x of and it's q. Sine of 247, 15 plus 253 equal to 246.12, therefore total length 246.12 plus 500 plus 273.25. It's going to be 1019.37 meters. Okay, 35 minutes left. I guess we can go and check through some of it. Have a quick drink break though. Only distributed the mean of that. Standard deviation of 5. Eggs with a weight of more than 67 are classified as jumbo. So normal CDF from 67 to infinity. 60 is 0.008. Normal CDF of 67. 75 of 5 of 60. 2A, the heaviest, fetch a higher price. What's the minimum weight of these? Let's try it the other way. Interactive, continuous, inverse normal CDF. The heaviest, fetch a higher price. So to the right, going up to the right, I'm going to have 0.0005. Divide by 100, I've got to add 2 zeros. So yeah, mean is 60 76.45. Mean number of kicks sold in a day, so 0 plus 0.2 plus 0.5 plus 3 times 0.35 plus 0.4. If each kick costs $20 to make and sells for 50, what is the expected profit or loss in that day? So 30 times 2.15 is 64.5. Explain why. P is 0 equals 0. Boom. You have 1, 3, 5. So if you have 1 left over, you only sold 2. 2, 5. You have 2 left over, you only sold 1. You have 3 left over, you sold none. 2, 5, 0.2 plus 0.1 is 1. Determine the rate, so differentiate 4x plus 1 over 2x squared plus x plus 1. Wait, no, I don't want that. I want this. Given x equals 2. The decimal 9 or 11. Explain why h of t equals that. Okay, got that. Total change in water over the first 2 seconds. Oh wait, I thought it disappeared for a second. Okay. So yeah, 0 to 2. First 2 seconds, yes. Dx is 1.3. Why did I do 0? That's a bit odd. Why? I mean, why did I do 1? Sorry. Should not have done 1. Should have done 0. Good thing I checked. Don't know what I'm doing. So ln of 11 is 2.3 or 2.4 centimeters. What is ln of 56? It's just 4. Total change in the water level over the first 2 seconds. The net change is the derivative. And that from 0 to 2. Yep. Was initially empty, so I'm going to solve an integral where I'm going from 0 to some value of y. Where I have 4x plus 1, 2x squared plus x plus 1 dx. That's going to equal ln of 56. And I want you to give me the value of y. So 5 or negative 5.5. Clearly t is greater than 0. So k must be greater than 0. So then 0 to 5 seconds. The points of the intersection of the graph of f equals x. So let me graph and table this bad boy. Let's do e to the x and then x. Let's see. Default. Looks pretty tangential to me. Obtain the coordinates. The point of the intersection of the tangent of the graph of x. The tangents are the same. Or if one is tangential to the other, it has the same derivative. So it's 0 and 1. C is 1. Sketch the graph and the x is below. And find the exact area between the graph of f of x, the tangent line, and the line x equals ln of 2. So the tangent line is below it. So it needs to be minus that. So let's go main. Let's go integral from 0 to ln of 2. Well, we're going to have e of x minus 1 because it's been taken away. And then what's the exact area? So negative ln of 2 squared over 2 minus ln of 2 plus 1 units squared. Given that g of x is the inverse function of f of x, alright, definite integral up use to determine the area between the graph of g of x. Solve ln of x is equal to 0, x is equal to 1, so 1 to ln of 2, ln of x. and f of x was just e of x, so it should be f of x dx. We'll say maybe therefore area equal to that. Okay, estimated 20 business failed the first year. A business advisory group takes random sample of 500 businesses. An employee suggests the use of a binomial distribution is appropriate in this case. It is appropriate that at most 120 businesses fail in the first year. So CDF from 0 to 120, we have 500 people, and the chance of failure is 0.2. 0.9877. Approximate distribution of the sample proportions of the small businesses that fail at the end of this sample. 0.2. Sample times 0.8 over 500. 0.0179. I mean, that's 2. The probability that the sample proportion of businesses that fail by the end of the year is less than 1.08, so negative infinity to 0.18, 0.0179, and 0.2, 1219. By January 2019, 90% of the 500 businesses that failed, calculate 95% confidence interval for the proportion of new businesses that failed in the first year. So statistics, calculation interval. 1 proportional, 95, 90, 500, 1, 4, 6, 3, 2, 1, 3, 7. Proportion is that, yeah. Do another random sample of 500 businesses that start in 2019. Calculate the sample proportion and its margin of error. Sample proportion is 80 divided by 500, which is 0.16. 95% confidence is 1.96, so 0.16 times 1 minus 0.16 divided by 500, 0.0321. Calculate the confidence interval, so 0.16, 0.321. 0.297, and then I do plus 1921. It's a large amount of overlap. The sample size is reduced, but with the effective confidence interval, margin of error is proportional to 1 over the sample size. So if n decreases, the margin of error will increase, and the confidence interval will get larger or wider. Clear success or failure, Bernoulli trials, probability of business failing is constant for all businesses. Not valid. Clear success or failure. 20 components in one day, so x ln of 2x plus 1 over 3 minus 2x plus 120, given that x is equal to 20, $104.76 gets the graph. If I differentiate this, I solve answer for 0, we get 74.29. Move 10 set to 10 and give me like 50 to 280. It's a different value than what I got here. $74.205, 71.21. If I zoom out, does that get like, does that change? No, it's 74.205. 0.43. Manufacture 74 components, so the total cost is a minimum of 95.43. Estimate proportion of residents for suburb users library. Estimate 95% confidence interval with a proportion is within an error of 0.01. So I'm so 0.01. I literally have my foot on my wall because I'm a bit bored checking all of this. I'm not gonna lie. 9604. And it was the maximum margin of error in estimating a 99% confidence interval. So 2.576 square root of 0.5 squared, 500. That's 50. 0.0576. By setting aside the library, excludes people who do not use the library at all, leading to undercoverage. Asking only at lunchtime excludes people who may be at restaurant for lunch or still working, or simply won't be going to the library that day, leading to undercoverage. So we order first place into the oven. What's that? So order 5 minutes after we place into the oven. It's 200 minus 175e to the negative 0.07 times 5, 76.68. What changes can be made to the temperature at which the oven is set to in order to achieve? So I'm going to solve that 100 is going to be equal to some x minus 175e to negative 0.07 times 5. 223, base temperature 224. Determine the rate of increase in temperature 5 minutes after being placed in the oven. So I'll differentiate u, but have this as an x instead of a times 5. Oopsie daisy, I should do that. 12.07x. 49 divided by 4 is 48.4. So we know this value, given that x is equal to 5 in the decimal, 8.632. So we might have this rate of change of water. So as time increases, that value there approaches 0. That limit of x approaching infinity of this. So now its syntax is 0. Rate of change decreases as time increases to a minimum of 0. 0 degrees Celsius per minute. This is such that when t equals 100, ETC, therefore temperature no longer increases as the water is boiling at this time. Okay, so then expected value is the mean, so 0.8 times 9 divided by 5 plus 32, and standard deviation is 4. 5 plus 32, 3344, 3272. I'll make this 3272 look a bit nicer. So the probability that the temperature refrigerator is above 1 degree Celsius, so above, that means I need to do 1 to infinity of 0.4, 0.8, 3085. Distribution is not symmetrical, as would be expected of a normal distribution graph. Okay, the amount of probability is above 1 degree Celsius, so I'll take an integral from 1 to 2. 3 on 4x to the power of 3 minus 3x squared plus 3x dx, 0.3125. And then can be given as q in the following. So I mean I showed it, so yeah. Maybe I'll show how I got this minus 150. So it's minus negative 150 plus 0 plus 0. So then this is 500q, or 0 exactly as how they did. Minus 150 cosine of q on 15. Okay, minus q squared plus 150. Determine to the nearest meter the value of q that will allow the sheet to graze over the maximum area. So differentiating 500x 150 cosine of x divided by 15 minus x squared plus 150. This gives me that. So then I solve this equals 0. Radians. Solve and differentiate. 247, what's nearest meter? So 247. So then this given x equals 247. 67550. And then so then r of x is going to be, so differentiate 10 sine x of 15. 213 cosine x of 15. Q equals that. So then I want to integral from 0 to 2 q, so 47. Square root of 1 plus this bad boy. Oops. I'm going to put u inside there. Then I want to square u. And I say dx. Ooh. 273.25. G to h is the value of r at q. So the value of r at q is u plus 150, given that x is 247. Wait, plus 150? It's plus p. P is 253. 246.12, 273.25 plus 500. Alright, I'm going to end it there and then start marking. So let's get started. Welcome back, guys. Man, we seem to be getting lower and lower scores for methods. 92.6. I wish I wasn't, I wish I was lying. We lost 2 in calculator 3. And then again, we lost 9 in calculator assumed. Yeah, not very happy, but it's alright. So this will look good. We lost 1 mark here because here when I was rearranging, because I think initially I had this as 0. So when I times everything, I times this by 4. I was like, I'll just leave the right hand side because it's going to be 0. But I forgot to times it by 4 again to get it as a nice one. But then I gave it follow through marks. But really, A was 2. I think D was 4. Yeah, D was 4. And then C would have been -6, I believe. Let me check. Yeah. 3. Where's the question? Yeah, D is 4 and C is -6. But yeah, I gave myself follow through marks for it because just that one mistake. Everything else is fine. And then here we lost another mark because I swear I was checking for percentages in every other question except for this one. So yeah, got the correct working, just didn't state the final percentage. But everything else down here was fine. Yes, they did want to see you do this limiting thingy move of you. So yeah. Alright, gonna move on to calculator assumed now. Okay, onto calculator assumed. Lost 9 marks. The first 3 marks we lost are right here because I just misinterpreted what was happening. I must have skimmed through making 4 birthday cakes, because what happens is that obviously you're gonna have to pay the cost to make all of them, but then you're only expected to sell a certain number. So the cost would have been $80, like no matter what, you made 4, but the expected income was only 107.5. So then you take them away, you find your expected profit. I was thinking that you do it on a per cake basis, and then you expected, obviously then you would still have to pay for the other cakes that you didn't sell. So yeah, that's just bad by me. Marks. Here you had to actually explain it with words rather than just saying HT equals that, which is like, oh my god, that's so silly. Yeah, I should have included units, but you know, whatever. And then, but yeah, here I can't believe that they actually want you to fully explain. It's like, so you have to say that h, the derivative, had the numerator as the derivative of the denominator, and then so then h of t is going to be the natural logarithm of the denominator, and then plus c is included as any constant value could be included. Wait, let me see their wording. Where am I at? Plus c needs to be included in the function as any constant could be included here. Must be included, which is the constant of integration, because it's like the family of whatever. Plus c must be included as any constant could be included. But these are right, these are right. These are going good. Pretty good. Oh yeah, you could have just said sample size is large rather than n is greater than 30. That's another thing I got to think about. Sample size is large. Yes, correct. Not enough evidence conclude that financial advice was effective in reducing proportion of failed businesses in the first year, which I mean, I don't know. It kind of explains provided in financial advice. So yeah. I give myself the mark for that anyway. But let's see. I think you got 2 marks for calculating the confidence interval. Yeah, and then 1 for referring to the overlapping, and then a correct conclusion. I said that overlap, and then hence not enough evidence conclude that the financial effect was effective. Here was a bit odd. I haven't heard back from people yet about what they think. Well, actually, I say the question is similar enough to this. Yeah, never mind. I literally just got it like 4 minutes ago. That's someone who's starting to agree with me. So yeah, 2 assumptions. They gave me 3. Let me find it. 1 assumption: the businesses fail independently of one another. Unlikely, because like if they're similar businesses, they're likely to fail together or succeed together. Or you can even talk about the competition there. Probability of a business failing is the same for all businesses. Unlikely, because the different things I expect to have different probabilities of failing, and the probability of failure is fixed for the year, which is also unlikely, because the probability will change depending on different conditions over time. So I said constant for all businesses. I said that's not true. And then I also said that this one wasn't actually in the marking. However, there was a question exactly like this. I think, was it the 2021 exam or something? I don't know. One of the other exams, and they said a clear success or failure with a Bernoulli trial. Was one of the other assumptions you could have made, which, I mean, I think that one was for voters, and obviously voters are either gonna vote or not. So in businesses, I also are gonna either fail or not. So I gave myself a full marking, even though it's not a marking key, because it was in a previous marking key. So it's a bit silly. And then here, I skim read hundreds of dollars. So yeah, I lost a mark there. I also lost a mark here because you have to compare it to the value at 75. But you had to say, got a mark for saying minimum, and then I got a mark for saying 74 components. But you have to compare to 75 to get to that conclusion of 74, which I actually did on my CAS. You probably heard me like mumbling under like 75, blah blah blah. But I thought, yeah, I thought to the same decimal places it was the same essentially, so I didn't bother. But it's because it's 100, it would actually cost more. So then coming down, The next mark we lost. Here you could have also just said 223, but I think that's a bit odd because if it's 223, you won't actually reach 100 degrees Celsius at the time. So yeah. Here I lost the mark because you really needed to say when or it'll approach TO, not 100 degrees Celsius, which is fine. Let's see, bada bing, bada boom. Yeah. Because I said it approaches 100, but oh yeah, I really should have said maybe approaches rather than equals. But yeah. And then yeah, I just lost the mark for not saying it. So it was TO specifically instead of 100. I lost the mark here because when you're calculating standard deviation, it doesn't care if you add or not. It doesn't care for any change in the mean. It changes for the changes the variance. So I didn't have to include plus 32, so I just had to do minus 32 of that. And then here. Oh yeah, you could have also said this about skew to the right, I think they said. Skew to the right, yeah. Ah, bless me. And then I think down here we did everything all good. Yeah, everything down here was correct. So again, a lot of marks lost to explanations, a few marks lost to math. I think this time was actually pretty even in math. In math, marks lost to explanation. I remember last exam, explanation marks were terrible. And by last exam, I mean like 2021, because I did 2022. Because I did 2022, and then I went back to do 2020, and I'm going to do 2023 later. So yeah. Alrighty then. Thank you guys for watching. We'll do 2023 next. I'm really sorry about not getting out these videos fast enough, but hopefully future ATAR students can watch this. I wasn't really expecting current WACE students to be watching this because we should be studying, not watching other people study. But I think for like, I don't know, year 11s or whatever, or future ATAR students, it could be a good resource. Especially, just skip to when I'm marking so I go through the mistakes I make. Yeah, so yeah. Alrighty then. See ya.